let me pull it a little bit down. Yeah. So when we add a charge to it, what conditions will arise? No. Where do this charge? This charge will reside on the surface. If it will not, it will not go into the material of conductor. Will agree? Let A be the area of cross section of this one. So we'll define few terms. Area of cross section of plate. No. How to find out the electric field due to this? So here the charge which is present, here, so it will produce field in this way. Why charge should be distributed uniformly? Look at the radius of curvature. It is everywhere same, no, infinite. So charge will be distributed uniformly. Okay, these are lines of force similar to non-conducting charges sheet. And the field will be uniform. This one. So now we are going to discuss, we have to calculate the electric field. Now what is the surface charge density? Let it be sigma. So what is the sigma? Sigma will become here equal to Q by A. Charge on a surface. So I given a charge, let's say 2Q. So what that 2Q will do, a part of Q charge will go here, Q charge will go here. Sir, what about charge? Why not charge be here? It's a thin plate. To make you understand the diagram, I am just showing it thick. But irrespective of thin or thick, it doesn't matter. And how to calculate this field? Can we apply Coulomb's law? The next question comes. Can we take help of Coulomb's law? The answer is no. We don't have anything from Coulomb's law. Only for point charge we can find out Coulomb's law. Then what is who is going to help us? Definitely the Gauss law here. And prior to that, we know something. What should be the net electric field inside the conductor due to static charges? Should be 0. So what should be the field strength at point P? Must be 0. So this particular charge, okay, okay, the field, net field inside the conductor should be 0, that one. So this positive charge, what field it produces here? This positive charge will produce field towards right. So the net field inside the conductor will become 0. Getting the idea? This one. So here, what we do is like, we will take a point P1 here and another point, I'll take it P2 here. Let me assume a Gaussian cylinder. Cylinder I need, yeah. And I'll assume cylinder inside also. Okay, here. There's a cylinder. Okay, let me shade that. There's a very fundamental, rest all very easily we can manage. Only this concept has to be, clarity is needed. There's somewhere inside, there's a Gaussian cylinder. Able to understand? We assume cylinder. So there are 2 points are there. One point P2. So how is E bar? E bar is like this. We know what is the electric field strength at point P1. Must be 0. Because the point P1 lies inside the conductor. So here N cap, here N cap. The area of cross section, let it be delta S. Now what is this? This is a Gaussian cylinder. So now let's calculate the thing. The net flux should be equal to E bar into like a E bar into delta S. Flux due to both the cylinders. I'll write in this way. Flux due to cylinder 1 will be 0. The reason for that there, the E bar itself is 0, no? There are two cylinders are there. One cylinder inside the material, other cylinder external to the material. So what about E bar here? Because net field is 0 here. Because discharge both will produce. The net field will be 0. Okay, this one. So then what about the field strength here? It is E. So flux will be E into delta S. This should be equal to Q in by epsilon naught. Okay, where the charge is present only on outer surface. So what should be the Q in? Charge enclosed by the Gaussian cylinder should be equal to sigma into delta S. So what is the electric field? Sigma by epsilon naught. Same, that field is same thing here also. Some students, if you look at some books, no, they are given the other way explanation. Instead of assuming cylinder inside, they have just assumed it here. They assume one more cylinder here. You'll get same answer. But I should assume a Gaussian cylinder inside the material also to show that net field inside the conductor due to static charges must be 0. This idea. I will put another similar diagram so that it will be easy for you. The what all I discussed now, based on this, you have a chapter called as a capacitor. It just revolves around this idea. We can also think in this way, nothing wrong. Yeah. So one cylinder, one student, what it does, you will assume a cylinder like this. Other, you will assume here, not inside. So there's nothing wrong by the student. You will get same answer. You see this. So actually, this is the purpose. Actually, before entering capacitor chapter, the next chapter, no, we need this. This is the most fundamental thing which we needed. Yeah. Now, what about the E bar? E bar here is E. No need of inside, no, and the E bar here is E. N cap, delta S. This is the surface 1, surface 2. What about charge? The charge this is iron, surface charge density sigma. Now, what is the net flux? Net flux should be equal to flux due to surface 1, due to surface 2. Due to surface 1, how much? E into delta S. Surface 2, E into delta S. What about this one? Q in by epsilon naught. What is the charge enclosed by both the cylinders? Sigma into delta S, sigma into delta S. This is 2E delta S. By epsilon naught missing. When we solve it, both are same, nothing wrong, both are same. Why flux is sigma delta S? This cylinder enclosing charge, even this cylinder enclosing charge. Like previous one, sir, why there you didn't look at this cylinder? Is there any charge present here? There's no charge present here. I think I'll change symbol 1. So yeah. Look at no. Is any charge present? No, the charge is present here. That's why I wrote E delta S, sigma delta S. So there's no charge present here. Charge enclosed is only by this cylinder. So sigma into delta. There's no charge here. Whereas here, I assume 2 cylinders. Some books they're given like this. Some books, both are correct. But this is more justified. Why we should take help of this one? Because we have to. Every point in the electrostatics, whenever conductor comes, net field inside the conductor due to static charges must be 0. I have to reflect that idea. This one. So now, so what is the electric field? It will be sigma by epsilon naught. Okay, there's a one side. Huh? So what is the electric field due to a conducting like a charge sheet given by sigma by epsilon? What is sigma? Surface charge density, charge by area. My voice, okay, this much. I think check your internet, ma. From your side, this is from, there's no problem with the internet now. So there's not like mobile data. Okay, we'll take the, again, see, do we think that we are really